a quick video on using similar triangles to find unknown sides. So first of all, we would like to notice the evidence here that these two triangles are similar. One piece of evidence is that their corresponding angles are congruent. Let's suppose that the blue angles are 20 degrees. Let's say that we know that. Then we would know 90 degrees and 20 degrees for each triangle, which means that the third angle must be 70 degrees for the small triangle and 70 degrees for the large triangle. So that would mean that we have three congruent pairs of corresponding angles: corresponding, congruent, corresponding, congruent, corresponding, congruent. They're in the same place. The other piece of evidence that these triangles are similar is that their sides are proportional. So I'm going to write the proportion as a fraction large triangle over small triangle. So then if I start with the large triangle, I have sides that are 12, 4, and 4 radical 10. And if I put the small triangle corresponding sides, 6, 2, and 2 radical 10. So that means that each of these sets of sides will have the same value. So 12 divided by 6 is 2, 4 divided by 2 is 2, and 4 radical 10 divided by 2 radical 10, radical divided by radical, those cancel, that's 1. Then 4 divided by 2 is 2. So that tells me that I have a scale factor here, which is multiply by 2 to go from small to large, and multiply by 1/2 to go from large to small. Suppose we have this diagram with a smaller triangle and then a larger triangle outside of it, where we know that these are both right angles. So if these are both right angles, then we have similar triangles, because this top angle, angle A, is going to be the same for the small triangle as it is for the large triangle, because it is the same angle for both. Then these are the same because they're given to us as right angles, so they're both 90 degrees. Again, let's suppose that you had 40 degrees right here, then that would mean that this would have to be 50, and this would also have to be 50, like that. So you have 3 pairs of corresponding angles that are congruent. So you have similar triangles. That means you can use the fact that the sides are proportional. So here on the small triangle, you know that you have 4 and 4. Here on the large triangle, you're trying to find this one. This is DE. And you know AD, but be careful. AD is not 2 or 4. AD is 4 for AB plus 2 for BD. So this is 6. So in this case, it should be easy for you to see that this side, DE, would then be 6. But if that were difficult for you to figure out, you could leave this as X, and you could write a proportion. We'll do large over small. So you'd have 6 over 4 for these ones equals X over 4 for these ones. And then you could multiply both sides by 4, or you could just see that this number would have to be 6 for them to be equal. Finally, we ask ourselves, do we have similar triangles here? We do, because we have one set of congruent angles that is given. Then we get another set of congruent angles because vertical angles are congruent. And then if we have 2 pairs of congruent corresponding angles, then we must have a third pair, because when we subtract these angles from 180, they'll be the same. So let's say that here we had, this looks like about 80. That would also be 80. Let's say here we had 60. That would also be 60, which means the only thing that this could be would be 40. and that means this would be 40. So there's your 3 pairs of congruent corresponding angles. So then let's suppose that we were asked to find this unknown side. Let's say we knew that this were 10 and that this were 8. And we were told that this is 2. So this example would just be a little bit weird, but stick with it. Thanks. So what proportion would we write for large over small? So our 8 is in between the red and black, sorry, our 10 is in between the red and black angles. So it corresponds to the side that is also between the red and black angles. So that's X. And then our 8 is between the orange and black. So that is the large one that corresponds to the small one also between the orange and black, which is 2. At this point, we would simply cross multiply to find X. So we could say 10 times 2 is 20, and that equals 8 times X is 8, rather 8X. Then we could divide both sides by 8, and we would get X equals 20 over 8. We could simplify that as a fraction to be 5 over 2, or 2.5. And that would be finding an unknown side when we have similar triangles from a diagram like this, where we use vertical angles.